Welcome. We are now live at Visual Arena, Lindholmen Science Park in Gothenburg. So today we have a very interesting agenda. We will talk around the theme to accelerate the transformation from physical to virtual. We will start with 3 presentations. Michael Kirash will talk about the value of XR in virtual development. That will be followed by Greg Jones from NVIDIA talking about the concept of streamed XR. Then we will have Stephen Horton from Volvo Group Trucks Technology talking about the power of collaborative group VR. We will then look on a demo. The demo is leveraging NVIDIA's CloudXR technology. It's powered by IC.IDO. The demo is developed together with Volvo, and we will experience a cross-functional group review in a streamed VR application. Then we will have a panel discussion. Steve, Greg, and Michael will join me, and we will also welcome Åsa Fast-Berglund from Stena Innovation Lab at Chalmers. We will also have a Q&A, so please chat your questions throughout the event, and we will take these questions to the panel in the end of the event. So welcome, hope you will enjoy, and with that I would like to welcome Michael. Michael, welcome.
Thank you very much.
The stage is yours.
Thank you, Jonas. Hello, everyone joining. It's my pleasure to lead into this event with the first presentation, the value of extended reality in virtual product development process and why deployment is disruptive. So in this context, I want to introduce the human-centric product and process validation solution IC.IDO to you. And since we will talk most of the time in this event about what we can achieve today and how the future will look like, I thought it's a good idea to start with a short look back where we're coming from, since the trend and the journey that we have embarked on tells us a lot on what's next. So if we look back at the gate, then we can see that XR technology, namely augmented reality and virtual reality, was already past the Gartner hype cycle techno peak, and the technology matured, of course, over the years. 5 years ago, the consumer class headsets arrived, and actually that has also a big impact, where 10 years ago it was just limited access for real virtual reality specialists to work with solutions like ours in CAVE and Powerwall environments. And then the company started more and more to involve more people and train simulation specialists with using the technology on jobs to be done. And this trend now goes further. And actually now we are discussing mainly about extracting real industrial customer value and talking about how to achieve operational performance and going really broad in deployment scenarios using mobile devices and so on. So we will see more of that then in the next presentations as well. So this said, you might ask yourself the question, where and for what can I actually use IC.IDO? And there is a relation between operational performance and focus. So IC.IDO is dedicated to create value in manufacturing industries product development cycle, from integration engineering to manufacturing engineering, helping companies to by the means of XR-based experimental discovery, validation, and communication to achieve mainly the targets on reducing the dependencies on physical prototypes and pre-series builds. And we have 2 dedicated addressing the different needs. One with a clear focus on product integration validation, and the other solution offering covering the domain of human-centric assembly process validation and human-centric service process validation. So this said, let's jump into how experimental discovery really looks like with an example for product integration validation. We can see here in the clip an engineer working with an HMD, and in this case it's a cable laying process, and the engineer is validating the design for either in this case the assembly process, but could also be the service process, or checking is the design feasible for the product in operation. So going now into detailed analysis and self-experience while laying the cable. Is the cable long enough for assembly or disassembly? Are there any problems with clamping, binding, pinching, or so? And are there, or might there be maybe too close to any heated areas or collision or abrasion? So these are typical questions that can be analyzed in a first-person experimental discovery. So next example is focusing on communication and collaboration. As said, it's a high value to enable multidisciplinary teams to exchange on concepts, do team reviews, and discuss and communicate on the impact on the proposed assembly tooling, the production resources, or simply the efficiency of the assembly process. In this case, we see two engineers in front of the Powerwall interacting with the product, while in a completely different remote location, an engineer with the HMD is interacting at the same time with the same product, and all are talking to each other, discussing potential issues and aligning on solution concepts, and even having the ability to involve also stakeholders and downstream partners. So this is achieved, and actually it's good time to start dreaming how future can look like and what is the next opportunity for extended reality. And this picture should simply visualize that maybe it's really everywhere in different environments. Is it the classical Powerwall or CAVE scenario, some other work environments for collaborative workspaces, or is it work at home environments and people are connected? And there are really some exciting technologies arriving soon that actually will allow a lot of these opportunities. And we will see some of those in the other talks. So I will really make here a pause, not going into detail, leaving it to the others, because actually here's a certain break. Let's look at what is actually then the disruptive part of the story. So usually companies still have established methods to do the job, like team reviews with on-screen captures that they discuss, or they have physical prototypes that they have workshops on and discuss and detect issues. But through front-loading, these established methods are replaced. They are replaced by a first-person experience on the virtual product. That itself is disruptive. And to utilize, it's absolutely required to integrate this kind of solution into the business process, managing the data pipe, also rethinking the decision and communication process, building the digital trust, and involving actually the stakeholders, and ensure that replacing the established methods will be accepted by the teams. So this said, in many discussions we see that the required effort and the acceptable effort can be an issue. So definitely time to review matters. This is why, independent from the actual IC.IDO solution, it's a clear target to minimize the requirements to prepare and optimize the data, with a clear focus on not doing the job once and then not use it anymore, but having persistent virtuality. So, and also we really try to avoid the need for any specialist to code VR with non-engineering relevant inputs. So the vision that we follow is to offer a solution that is completely compatible with a very agile development process and that allows for ad hoc Scrum-like virtual workshops. And this is what we actually will see in our demo later. Then the third component is implementation and adoption. So I mentioned the business process. We also help and discuss with our customers actually the adoption of IC.IDO into their business process. And the usual process is really using classical process analysis tools like CPOC, for example, and then working with the stakeholders, aligning on their transformation objectives, identifying the use cases to start with or to expand the deployment, and then co-create an implementation roadmap. So the point is, it's not just software, it's software plus success engineering that is so important. And this said, I want to close my presentation with a 1-minute movie clip that really wraps all up what is possible in a full IC.IDO deployment scenario as of today. So we can see here teams around the world work together in different time zones. We can load the full manufacturing environment and then have detailed interactive analysis on work cell level with the teams exchanging from different locations. They all are immersed, experience the product. They discuss potential solutions, either desktop or in immersion. And work very interactively as a team around the globe. So thank you for your attention. And yes, Jonas, that was my presentation.
So thank you, Michael. Thank you for starting the XR event today, giving this introduction.
Yeah, see you later.
And see you later. Okay. So now before we move to Greg's presentation, we will launch a poll question. So that poll question will be launched and you will see some alternatives. And then while the poll is running, I would like to welcome you, Greg, to join.
Thank you.
Hi,
Nice
sir.
Here.
How are you this morning?
I'm good, thank you. Thanks for having me be part of your presentation here.
And thanks for joining. I know it's early for you back in States.
You know, at NVIDIA we're always up, so it's okay.
Yeah. So it's a pleasure because now with Greg from NVIDIA, he will start to enter a little bit what we are now seeing for the future. So with that, Greg, over to you and see you soon again.
Thank you, sir. Thank you. And thanks to ESI for letting me talk on one of my favorite topics, and that's streaming XR. So I'll get into it pretty quickly here with a quick statement of one of the interesting things about where we're at in time is we haven't been doing XR in production for that long. So I think of the XR market and its age, its history in terms of GPUs. Of course, I'm with NVIDIA, and so looking back just in 2015 when Maxwell was out, that was really the first architecture we started seeing production XR VR being used, and of course that was with I think the Oculus Pre and one of the early HTC headsets, and a lot has changed in the GPU power spec over time. And as fast as that power spectrum changes, as fast as rendering gets more and more powerful, we see the resolution, the frame rates, the field of view, model complexity, model size, materials all get complex and become heavier workloads. So it's been a really nice increase in graphics power, and then the utilization of that graphics power has been really nice. It's been a nice continuum. The graphics cards I'm showing, and the reason I end at the A40 is not just because it's the most recent graphics card that we've put out. It's also because it's an indication of where the graphics card is going, the location of the graphics card. So certainly in early XR, that was a workstation event, and most graphics were workstation events. Now we're starting to see the graphics card, not just the AI card or the compute card, but the graphics card moving into the machine room, moving into the cloud. So that GPU location is changing over the last few years, and that's an exciting thing for us. When you think of XR, one of the things I want to point out is the reason we're tethered to these heavy graphics cards like the A6000 and the A40 is if you think of the rendering workload, the graphics workload, it's pretty extreme. If you compare it to gaming over here on the left-hand side, that lower picture is a gaming. It's 60 frames per second if you're high-end, ultra-high definition, single screen. Now, if you move up into the panel showing VR, we're at least at 90 frames a second now. We're doing two pairs of images, high resolution, and that workload really increases. So that's the predominant reason you've been attached to a graphics card. And then over here on the right-hand side of this slide, I talk about the fact that we have this motion to photon latency of 20 milliseconds. If you missed your 20 millisecond motion to photon, so the time it takes for the user's head movement and the graphics to update to that head movement, you have about 20 milliseconds or you induce nausea. I think the entire audience of this talk knows about that. But that's another reason we've had these, high rate, big graphics cards. That latency problem, that motion to photon, has always been the block for streaming XR. So if you're rendering and getting the image to the headset within 20 milliseconds, putting in a 5 to 50 millisecond network latency, not to mention encode and decode, just didn't seem possible. In fact, when I first joined NVIDIA back in 2017, I talked with engineers and they said streaming XR is not possible, right? We'll never meet that 20 millisecond frame rate. Well, the kind of secret in the industry, or it's not so secret, is that even with tethered VR, we don't typically hit that 20 millisecond motion to photon with the render and getting the frame to the headset. So we've already had to come up with a solution for missing this 20 millisecond window. That solution's late latch. I won't read this out loud. It came from a Unity forum post I found. But late latch is basically when we deliver a frame to the headset says, hey, it's been a while since I've asked for this frame. Will you please transform it to my current position? And so a quick transform, not a whole render, but a quick transform that takes roughly 3 to 5 milliseconds is done. And a user, for all intents and purposes, is in a 3 millisecond latency visualization. And that late latch is really the key to also streaming XR. So this is the architecture of CloudXR, and it's not an architecture that's unique to CloudXR. A lot of the XR streaming systems you see out there use a very similar strategy. And I'll just walk through this really quickly. So you have your VR app up here on the left-hand side, and that runtime talks to an interface. In the case of CloudXR, we're using SteamVR and OpenVR as the interface. We take that frame from SteamVR and we encode that, and then we stream that across the network down here at the bottom, take that and decode it, and basically hand it back to the OpenVR interface. And what happens is the headset, when we hand the frame to the headset, it asks for a late latch. But instead of going back to the original rendering GPU, we do that late latch on the client device, so on the headset. For instance, in an Oculus Quest 2, that XR2, that Qualcomm XR2 chip, does that late latch, and the user sees a 3 millisecond, 5 millisecond old frame. In the meantime, we've covered up a render, which could take anywhere from 10 to 30 milliseconds. We've got encode, which takes about 10 milliseconds. The network transport can be anywhere from 1 or 2 milliseconds to 50 milliseconds if you're using cloud, decode another 10. So we're adding 40 milliseconds of latency, 30 or 40 milliseconds of latency streaming. And what we still see with late latch is a really good VR experience. So that's kind of the first piece of how you do streaming XR. And that idea of putting late latch on the client side has really opened up the gates. This came along for NVIDIA. We did this in about 2018, and it's coming along with a really rapidly changing XR market, especially if you look at the consumer side, but also it's impacting the enterprise side. So one of the challenging pieces of XR is getting into an XR system with the tether, the tracking devices, the need for a large GPU. To combat that barrier to entry, of that complexity to entry, we've seen Oculus Quest, and now Vive is coming out with an all-in-one, the Focus 3. Pico has the Neo 3. These all-in-ones are coming into the market. They're changing the consumer market rapidly, and really what you're seeing is a 3x sales increase, maybe 4 or 5x sales increase in the consumer market of all-in-ones relative to tether. And we're really starting to see that exponential growth curve. In enterprise, it's about 50-50 right now. The sales of HMDs, about 50% are all-in-ones and 50% are still tethered. We do expect that to change over the year, especially with streaming. So we've got two really nice convergent market events. The emergence of these all-in-ones where you just put the headset on, your tracking is internal, the graphics card is internal, and you're suddenly in a VR event. There's no setup, there's just put the headset on. And then we have the idea of streaming. And this market convergence is really a big deal. It's taking us from, this old build of XR with at least HMD-based XR, where every XR goggle had to be paired with a workstation, a relatively expensive workstation, had to have a tracking system. And so what happened was, it's a really non-scalable type of system. This is the machine in your company that does VR. If you want to do VR, you have to go to that machine. When someone's not using that machine for VR, it's not doing anything, right? So a really expensive install, not used, constantly. And to get your data here, you usually had to get with a VR, technician to get the data on the server or on the workstation. Compare that to the streaming XR, and you put your headset on anywhere you're at, and you're immediately in a high fidelity, beautiful visualization, working with colleagues from who knows where. These three people could be physically, they could be anywhere, but they're in this room with this beautiful model. And that combination of all-in-one headsets and streaming XR is really a big deal. So, I'll go over some configurations here of what you can stream, how you can stream, what networks you can use. But needless to say, it's not just headsets, it's also handhelds. So a quick example, this is on an iPhone. This is CloudXR. We're using a high-end render of one of the Rimac EVs. And you can see it's an AR example. So we're in the lobby of NVIDIA's headquarters. And that car, of course, isn't actually there. It's being projected onto the iOS phone using ARKit. And you can see now with streaming XR, we can have these beautiful renders of very complex models. This is the full model, tens of millions of polygons, or tens of millions of polygons. So a really nice event, and it's, if I showed the video, it's really smooth. It's really a gorgeous render. So the configurations now, what you can think of is certainly here at my home, I have a LAN, right, a Wi-Fi. LAN, and I use my desktop as the server, and I use my Oculus Quest or whatever all in one, my Focus 3, to do VR. And I can do VR in my yard, and it's where I usually do it is in my front yard. It's got wide open space. That's the obvious configuration. The really exciting configurations come about when you start thinking of going to the machine room. So here, think of a data center, on-prem data center. So you're really erasing that upper left-hand image, and you're starting to instantiate that lower right-hand image in some of the images that Michael showed. So the distribution throughout your company through your Wi-Fi network, 5G is going to be a huge enabler. Wi-Fi 6 is an enabler. So there's a variety of ways your on-prem data center can stream to these headsets. And now those servers that are in your data center, they're virtualized. So if you're not doing VR on them, they can do VDI, they can do CAD packages, they can even do, compute workloads like AI workloads or data science workloads. So now we've got a computer that doesn't just have to wait for a VR user, and we have a VR user that all they need now is a headset. So your market really changes. Our distribution paradigm changes in the fact that you don't have to have a workstation, you just have to have a headset to be a VR user, and you can be anywhere the network reaches. When we think of putting this in the cloud, and I'm in Salt Lake City, Utah, and the cloud service I use oftentimes is AWS, and I use a instance that's in Oregon, so a few hundred miles away. It's about a 50 millisecond connection, and it works really, really well. I've done design reviews. I've even played Half-Life Alyx, and it's a great experience. So now we can start thinking about those instances being all over the world, and it really opens up a nice collaborative platform thinking of using cloud and XR streaming from the cloud, which who knew was even going to be possible. We were shocked when we first tried it. Now, as young as the XR environment is, the streaming XR packages out there, CloudXR being one of them, are really young, right? So we've seen some nice motion. We introduced CloudXR in an early release in 2019. We've added a lot of features, and there's a lot more to come. And so I want to just quickly touch on what the future of XR looks like. So there's a lot of devil in the details type of near-term needs. The SteamVR interface isn't particularly great for scaling. It's not a great corporate interface, and it's not particularly great for AR. So we need to look at different interfaces. That's going to be coming up really quickly. Security and encryption, that's another need that's really near term. So a lot of laundry list of have to do technical things. There's a growing number of devices, how to support all those clients. And then of course, network flavors and network topologies. If you look at a 5G network, oftentimes they have pretty high jitter, which is a really hard piece for streaming XR. So building optimizations for those networks. And then of course, putting more users on a GPU, knocking down that total cost of ownership of the GPU. These are all near-term things we have to work on. But once we get past those, what's really exciting is the fact that we're reaching back into a data center to do XR, which means we have a lot of compute right next to that graphics card. We have a lot of graphics cards in there. And so we can start thinking of split rendering, AI workloads. Just to give a couple examples, one of the IC.IDO nice examples I saw of ray tracing was they take this surface and they look for deformations so they can train people to see product deformations or product deformities in situ, right, in their training. And so where do you do that ray tracing? You certainly can't do it on an XR2 in a Quest 3. And you might not want to ray trace the whole scene. You might want to raster on one graphics card and ray trace on another graphics card, or you might want to ray trace in the cloud or in the data center and then raster on the headset and composite on the headset. So there's a variety of things when we start thinking about doing different renders in different places with different latencies, a lot we can do to really enhance the scenes we're doing in XR, our immersive scenes. What I'm really excited about is the thought of different compute workloads being right next to that graphics card. So you can think of right now in XR, when I go into an XR environment and I want to change a feature, I'm going to basically pull up a GUI. It's going to occlude my scene. It's going to break my immersion, and I'm going to make my changes, and then I'm back in my scene. What if we could use a conversational AI as a GUI? So basically a conversational user interface. So that's bringing an AI to the party. And so the thought of getting to work with AIs in our workloads in our graphics workloads is really exciting, especially for immersive environments. So the way we look at this, just to think, real future, is VR is our way of going into virtual worlds. And now we can go into a virtual world. We can work with colleagues, collaborators, and those collaborators can include AIs. Can be a generative design AI, could be a conversational AI. And then AR, one way to think of AR is it's the AI's portal into our world, right? So here's a world, the AI gets to see it through cameras, whatever, and they get to work with us in our real world, give us contextualization, give us information about the real world. So that's the future we're envisioning at NVIDIA with AR and VR, and what Streaming XR is opening up. And I really appreciate the time, and thanks for listening. And Jonas, back to you.
So thank you, Greg. Very interesting to listen to you, and also where our partnership are, let's say, taking the next step, leveraging CloudXR technology and Streamed XR. So with that, I would like to invite our next speaker. So now Steve will join us. Steve, are you there?
Yes, hello. Hello, fantastic to be with you.
So now we are a little bit closer to Sweden from where we had Greg. So welcome, Steve, and it will be now very interesting to listen to you and what you see is, let's say, needed in order to support collaboration. So over to you, and see you back in later this afternoon. Thank you.
Fantastic. Well, I really appreciate the opportunity to be here today, and I'm looking forward to talking to you about this collaborative VR. Before I get there, I want to give you a little bit of context behind why we think this is important. So a few questions first of all. How important is knowledge that we have within the company to making great products, right? The knowledge base that we have of the experts within the company. And, are we limiting the value of the virtual data we have if we can't communicate it in an effective way to the experts that we have? And finally, are the issues that we find in design, are they typically the ones that are presented to us, or are they the ones that maybe we haven't considered and are somehow hidden or in the backside of the design? So again, to give you some context here, so I started my career here with Volvo Group 17 years ago in the manufacturing group. And, what an experience to really understand the complexity of the...
Just a comment, you need to share the slide deck.
Let me try again.
Presentation mode.
Do you see?
The presentation mode is...
Okay, let me try again.
PowerPoint. Perfect, thanks.
Okay, thank you. So again, these machines that we build, these fantastic machines, I mean, we're talking, 12,000 parts or so that come together from all over the world and are assembled together in our manufacturing facility. But, more complex than that, the machines that we are building, these are the foundations of our customers' products and their livelihoods. And we build products that service many different applications, right? From garbage trucks and concrete mixers through to the the big on-highway vehicles that you see where people will sleep in the trucks and use those trucks as a mobile office as well. So in order for us to be able to service the needs of the customers, we need to produce, we have many different models, but within those models, there are thousands of different options that we give, from different engine types and suspension types, all the way through to smaller options within the cab that make the drivers work better. So we manage this enormous complexity and enormous variation within our products. Also, while I was in the manufacturing group, what I learned was, we had a team in the plant whose job was to work with the trucks. Again, these vehicles we're building with this complexity. We have one that comes off the end of the line every 5 minutes, and with the number of options that we have, every truck that's coming off the end of the line is different. So we had a team, and their job again was to work with these vehicles, and they, over the years had seen many different options. They understood the different customer choices that were there, and had a really in-depth knowledge from day-to-day exposure of working on the vehicles of really the inside of the truck. And this is an example from manufacturing, but we have these people throughout the company. But these people aren't, they're not CAD experts, right? These are guys that are working with the vehicles. So how do we bring, new product changes when we have this complexity in the products? So traditionally, we build physical prototypes, and those physical prototypes are useful for a number of different reasons, for validation and testing purposes, but they also serve a very key purpose in this transfer of knowledge that we have, both of the detail of the new product, and also this feedback from knowledge experts that we have within the company about that design and improvements that we can see. And so, if we take the example here, many times what I would experience is that we would have these physical prototypes, and what you would see is, people really exploring and looking around that prototype. Now, these people had seen, design reviews, they knew what was coming, but this was the first chance they had to really explore the truck. And so we got some, very detailed feedback when we went through these prototype stages. I took that, knowledge and understanding as I moved into the next role I had it in the company, which was to, bring these new products from the early design stages through to implementation. And what you start to realize is, this feedback is fantastic, but it's also very late in the product development cycle. Making changes after we've reached this point are expensive, and sometimes can lead to delays. So what we really wanted to do was look at, is there a way that we could, again, utilize the virtual data that we have in a more effective way? So, we took some steps here. I'm sure you've probably experienced something similar, right? Where we brought the experts that we had into a room, and we have what I call kind of a follow-along method, where we would display the virtual model, and you would have somebody there that was controlling and rotating that model, so that people could start to see and understand more of the detail of what was being brought. This was very effective. We were able to find and identify things earlier on, and be able to make changes before we got into the physical prototyping. But in one of these reviews, there was something that really hit me the one day, and that was that we found quite a major issue. And again, it was great that we were able to identify it and solve it. But what struck me was that it was maybe about 40 minutes into the review where we identified this. And more than that, it was the person that managed to identify it was actually the person that was controlling the CAD view. It wasn't anyone else that we had in the room that was looking at it. And what that speaks to, again, if you've been part of these type of reviews, is if you're the one watching, you can see what's being shown to you, but it's very difficult to explore. And sometimes it's harder to follow along. So again, this was very effective. We learned a lot from this method, but we were looking for, how do we do this? How do we get the same benefits that you get from that physical build, where people could really start to explore the truck for themselves and not just be shown what to look at? So then we took a step forward here. with VR. So we set up, what was a fairly typical VR setup. We had, one person in VR. We had a fairly small room. I mean, a few years ago, you were limited to really how far these, VR headsets could move. And then we would have, what that person was looking at was on a screen, and then other people would then watch the screen. Again, this was a great step forward. I mean, we've been able to identify and find issues. You start to give people that ability to explore the truck in a way that is now, instead of looking at on a screen, it looks like a real truck. It's at the same scale that you would have of a real vehicle, and that enables people to get more of a feel of what they're looking at. But we also found some drawbacks, right? There were some drawbacks that we found with this method, and that comes down to a little bit of the way the space is set up here. So first of all, with a small area, we have a big product. So you can't fit that truck, or you couldn't fit that total truck into that small area. And everyone said, okay, that's okay. You can use the controllers to move the product around. And while we could do that, what we found that, we had VR experts that were great at doing that. But when you try to put someone into that experience, again, one of these knowledge, very knowledgeable people that have been around for a long time, know a lot of things, what you found was they spent a whole time trying to figure out how to use the controller. And the focus wasn't on the product that you were really looking at. We also had the other practical problem of, if the product's moving around in this small space, you have to really watch people that they're not going to walk into one of the walls, right, in the room. So what typically tended to happen then was you ended up with a VR expert that was kind of doing the VR, and then you're back to this experience for everybody else where they're watching on a TV screen. And again, we get benefit, but you still have that kind of barrier to these knowledge experts. So when we talk about collaborative VR, this has been a fantastic work then that we've done with ESI to create an experience which, again, is more welcoming and enabling to be able to put, anybody into a VR experience. So we have a room that's large enough now to fit a full truck, and we have headsets now, with the CloudXR that give us the ability to be able to move around in this larger room around the total vehicle. In doing so, we put the product in the middle of the room. You no longer need to use the controllers to move. You simply walk around the truck in a natural way. The other thing that we've done is, again, we want to pull the people, instead of looking at the TV screen, into VR together. And what this does is facilitate a more natural dialogue between the people in VR. What we found before is, again, if you have one person in VR, other people watching, there's a lot of interaction of trying to get someone to look where you need to look. And, oftentimes, again, we have a group of people, maybe 10-ish people that are from, different groups that are trying to look at something together. And, if you only have a set period of time, maybe half an hour or an hour, if you're trying to pass all those people, through an individual headset, it's not conducive to a good dialogue. So again, this has been the vision. It is very powerful because it really gives you the ability to look at the product, focus on the product, and be able to have this, natural dialogue between different participants. So soon you will then see a really good demo that explains this better than this picture can. But I want to highlight a couple of key things. So one of the findings that we had that was really beneficial was a setup where, as part of the headset, you're in VR, but you're also enabling a partial pass-through of the view that the camera on the VR headset has. So you get this kind of mixed reality view where you see the truck, but you also see the context of the room that's surrounding you and the other people that are also moving around that room. You know, this was a key finding that, you know, this really made the comfort level of the people in VR or in this experience much more relaxed. You don't have that fear of hitting into a wall or not knowing what's around you. And what we found with this is that, you know, the feedback has been excellent from both experienced VR users and also, you know, VR novices that come together in this experience. And, you know, typically we can be in there for 30, 40 minutes and you find that people leave the headsets on. They have this natural conversation with each other, you know, in the VR experience. So with that, again, the challenge that we have is this, you know, complicated product, many different options. The big benefit we have in the company is a lot of very knowledgeable people, these experts from all the different groups. And again, this tool gives us a window to being able to enable that expert knowledge to be able to really see and understand the products and give us this, you know, valuable feedback early in the product development cycle.
Thank you, Steve. Very interesting to learn more about, you know, the needs behind leveraging and using the technology Greg talked about. And I think it was 2 years ago when we met you and you had this vision, or even more than 2 years ago. And as you said, now we will go into a demo where we will show a little bit where we are today, taking your vision, the need from an industrial company like Volvo, and leveraging the technology that is provided by our partner NVIDIA. So with that, Steve, I welcome you back a little bit later for the panel. And I would like to introduce Mark, my colleague, to the stage. Hi, Mark. Welcome.
Hi, Jonas.
So maybe you shortly introduce who you are.
Yeah, thanks for having me. So I'm Mark Niemann. I'm a member of the solution management team of IC.IDO in the business line of human-centric, reporting to Mike Kerouac, who was presenting and kicking off this event. I'm focusing on getting the right outcomes to the right time, at the right time for the right people, mainly. So it was a very, very, let's say, intense last 1.5 years, and I'm very happy to see all of people here in this meeting watching at what we've done in the meantime.
So let's take a look into what we have. So what we will experience today is a demo leveraging the technology from NVIDIA CloudXR. It's powered by IC.IDO. It's built together with Volvo, with the courtesy of Volvo. So let's start. And this is quite interesting because, as said, we are now supporting the use case that we heard from Steve. So we have a design engineer, we have a geometry architect, we have a service engineer, we have a manufacturing engineer, and we have an external participant, and we also have a facilitator. So maybe, Mark, you could comment what we now see on the screen. What's happening now?
So what's happening now is a disruptive innovation to me, because I worked for this VR expert stuff since 20 years. And what we see today is that we are getting non-VR experts into the session. And as you can see now in real time, it is as quick as possible to get those people which have never used VR before into the sessions. And you will later see in this video then how they interact. And this is great to see.
So the user, they take a headset and they go to this calibration point, and then calibrated in the session.
Well, they are already aligned to the product data or the process data they see in front of them virtually. So you see this empty room, but in the HMD, in the headset, the full truck is visible. And so, as Stephen mentioned before, walking in a real existing room, a the virtual product data, this wasn't easy in the past because it took a lot of technology expertise way ahead of getting those people involved.
But I guess the people we see, they are experienced VR users that have been trained on leveraging the
They are definitely not trained on anything like VR. They are doing their job. They have an expertise in building trucks like this scenario, so or whatever planes. So they have a job profile which is not being a VR expert.
So what Steve talked about, this is actually what we see here. So the people walking around, they are exploring the truck and are talking about the product or the process.
They are immediately immersed and they start talking about their job and not talking about technology. This is the great achievement we could have.
But what's happening there? They take a ladder and move in and then they walk up. Isn't that dangerous in virtual reality?
No, it isn't, because of this pass-through feature which Stephen and Greg was mentioning. So this XR mode is key and it is good for getting user acceptance. And it's completely normal for them to take this ladder, or they can use tools, real existing tools, the same way, and not get into danger because of bumping into each other or falling down a ladder. So it's a mix of both VR and real life.
And what is happening now?
As those experts are coming in and have different perspectives on the same data, we can switch the situations easily so that each of those roles can focus on their perspective.
So we could launch different use cases and scenarios.
And as soon as we have prepared the stuff and the system is up and running, you're completely free and you can benefit from all the IC.IDO features you are using.
It feels really natural. It seems that the people, when they are fully immersed, that they are focusing on the product, not the technology itself.
Yeah, it is like you mentioned. As you can see, the simplest behavior, going down to the floor, getting closer to the product data, talking, pointing. This is the natural way of doing things, but it's virtual now, and it doesn't require any mock-up.
So this is not augmented reality, it's really mixed reality.
It is mixed, absolutely. And this is, I think, what you see in the top right corner. I think the boundary conditions of the room itself is displayed at the same time as the virtual product, so that you're always aligned to your real environment.
So what we see then, what is this? This is an external participant.
This is the most important topic for the last 1.5 years because of the global pandemic. So this remote person here is okay inside this room, but it could be also remotely in another region. So because of this CloudXR approach, we can connect stakeholders from different regions.
So he could connect from another site. Is that even possible wearing an HMD?
It is, yes.
Okay, so you could connect different sites meeting in the virtual space.
As Greg mentioned in his presentation, I think there is this network in the middle, and when this is in shape, the rest is feasible to do for us as well.
But I guess this could really accelerate the digital transformation.
It is already transforming.
Okay. So what we see here is the HMD view. That's of one person and what that person see, and then we have the physical people. We see the avatars, and you said we have a see-through. Do we see the ghost of the real person also?
Maybe not in this video, but in real life, you see this ghosting and shadowing of a real person. So the avatar representation, the virtual one, is the upper body part, and the real body person is shown at the same time with the lower body part.
So it creates a natural interaction. It's easy to join.
Yeah, you know exactly any time in the session where the others are located, and they're in, let's say, color marked as they're chosen their green and yellow HMD.
And I guess it seems that the room is big and is a truck scale 1-to-1, so they are really walking around that.
Yeah, I personally experienced myself that this is a 1-to-1 situation. So probably the best situation you can encounter.
So virtual is equal to real then, or physical?
It is, yes.
Yeah. So could we have other use cases? Now we saw, an exploration. What do we see now?
So we saw these group review situation in which team leads do invite other stakeholders, but it doesn't need to be always a group meeting. It could be a personal investigation, also a personal assessment, or let's say a smaller size, 2 team members of a component, for example, would like to talk and analyze something. So it's just downsizing number of persons and doing the same.
So it's not only reviewing, you could also explore. So what do you see now? What's happening there?
They're focusing on disassembling a component from the front of this truck. So they just see if this disassembling sequence is in shape or not. So as they haven't seen this product in real life, when they work on this one, they do work in a virtual space, but they never saw this complete truck virtually.
And also using a cut plane that you could go in and explore the product.
Yeah, I mean, full beneficial of VR itself is embedded in the solution. Yeah.
Okay, fantastic. So more to come, I guess.
Yeah, hopefully. I mean, I think there is a great journey to go.
Okay, so if anybody interested to join, you could also reach out to us for this. So thank you, Mark. Thank you for helping me to comment the demo.
Okay.
Okay.
Goodbye.
So with that, I would like to then start the panel. So we will have Steve joining us back. We will have Greg also connecting from US. And with me here in the studio, I would like to welcome Åsa and Michael. So I think we have met all in the session before without you, Åsa. So maybe you do a short introduction of who you.
Yes, so my name is Åsa Fast-Berglund, and I'm a professor at Chalmers University in smart automation.
Thank you for joining us here. So Steve, let's start with you. So what are the current challenges to get people on board using virtual data? And yeah, what do you take on this?
Yeah, I mean, first of all, to say, we have and we use virtual data, for years in the design of the products that we have. I think, one of the challenges is can you get people, these experts throughout the organization, can you get them to buy into making the key decisions that we need to make based only on virtual data? Right, and we have quite a good example of this from something that we did, where we had a new design that was part of quite a complex part of the vehicle. We had shown the virtual data through, again, a traditional method where you sit down in kind of the follow-along method I'd shown, and we showed that to our manufacturing and our service team, and they said, yeah, it looks really good, but we really want to see a physical mock-up of this to be able to really, before we say 100%, yeah, but let's move forward. We asked them, well, what's your confidence level based on what you've seen? And they said, we're about 65% confident. That would have taken us probably 3-5 months, something like that, to have really pulled that together to the level that we needed. So we tried to review it then in VR. So we took the same virtual data that we had shown, and we brought those people into a VR experience. And what you find is when you have the VR, I mean, it feels more real. You have the one-to-one, experience, and you can explore around the truck. So we showed that data, and then the feedback afterwards was, okay, we feel like 85% confident now. Again, this was looking at the same data, and we're okay to move forward. So that was a big step, and it shows you, again, it's not just the virtual data, so how do you experience and how do you share that in an effective way?
That's fantastic. So Greg, how does the streaming change this, and how could that enable people getting access to extended reality?
Yeah, I think that review, a lot of it's comfort, right? How comfortable am I in the review system? So if I walk in and a technician tethers me up or puts a backpack on, and takes a few moments to get my tracking set up, I'm not seamlessly in the environment. If I'm not a VR user, I'm just not that comfortable. So already I'm going to be fighting the technology more than I'm going to be looking at the data. So a lot of what streaming XR is, forget the XR, forget everything. It's ease of use, right? I put the headset on, I'm in the review. I want to pop the headset off and say something to somebody, and I just put the headset back on. And I'm not thinking about the technology. I'm not in a new environment. I'm just looking at my data. And that comfort level isn't just with the data, it's with the technology. So I think to get to that 85% review and up, you need to be as seamless into the virtual environment as possible. And that's really what streaming XR is. And then if you extend that to things like training, I don't want to train in VR equipment. I want to train with my environment, right? So same thing. If my headset's the only thing that's in my way to get into training, and now suddenly I'm immersed in a training environment, I'm not battling technology and the muscle memory I'm creating and the other memories, that really translates to my work when I'm done training. So streaming XR just simplifies. It's simply easier to get into the system.
So it's as we saw in the demo, you take the headset, you put it on, and then you are in. So within, as I understand, less than 1 minute, 4 people were, let's say, launched and immersed into the VR session.
Exactly, and that collaborative piece is really key to both training and design review, right? To buy off, I don't want to be alone in there. I want to point to things and ask questions with collaborators. So that collaborative environment is also critical. And you can imagine, even on-prem, you know, if you've got 4 people in a VR system and they're tethered in the same room, you've got some problems, right, with those tethers. So streaming XR, you know, helps with that group collaboration also when you're in situ, right?
Okay. So also, what is the most beneficial areas within a company starting to leverage XR technologies from your point of view?
I think it differs quite a lot, but what we have seen is that VR technology is quite common used if you don't have a physical product or a physical factory, for example. I think it's quite beneficial because then you can also reduce the ramp-up time from learning to actually do the assembling or the maintenance, for example. And I also think that AR or mixed reality could be used when you have a mix between a physical product, but maybe some additional components, or you are rebuilding or reassembling or disassembling the product. So
a little bit what we saw with the ladder, for example, to combine physical assets and
I think it was really interesting to see the demo. Actually.
Maybe you would like to try it out.
Yes.
So Steve, do you have any example to fill in from your perspective?
Yeah, I mean, I think when you start talking about, you know, looking at physical product and overlaying, you know, digital or virtual on top of that, I think then you go into a whole nother set of applications. As you mentioned, training. I mean, I think that's one, you know, key area. Again, we have these, you know, complex products. So, you know, when you're training a new, you know, technician or a technician in a new area, or if you're introducing you know, a new design into that area, you know, to be able to both train them and then also make sure that the components are in the location where they should be. I mean, if you could visualize that, you know, instantly, that would be really beneficial. And another example of that too is, you know, when we introduce a new product, we will go through an audit to make sure that the, you know, trucks are built the way we expect them to be built. That audit process usually takes maybe 3 times as long when we're in, you know, the new introduction phase than it does once you migrate into regular production. And that's because there's a lot of work to, again, reference back to different drawings or reference back to different models. But again, if you could have a headset on that would overlay these are where the components should be, and maybe this is some information about those different components, I think that would be really powerful.
I think so too. So Greg, from your perspective, what's your take in extending this maybe to an even bigger scope?
Yeah, so I think, you know, one way to think of it is I really try to not think about XR. I think about what the XR is driving to. So this digital overlay and the mixed reality type of thing. So if I have an expert in the field, I can distribute that expert all over the place with this streaming idea. So I put a headset on. I'm a junior maintenance person. I see something I've not seen before. I can get any expert into my headset now and share my view and have them point to things. They can overlay data. So the broadening of data and expertise throughout your network with these streaming technologies is really fascinating to think about, right? My experts don't have to fly around. My design review experts don't have to fly around, right? So my North Carolina plant can work with whatever plant in the world, with whatever design expert in the world, and they can be anywhere. There's a network. And so this distribution of expertise is what this is enabling. And I think the use cases just go wild from there.
So a lot of possibilities, and also, do you see any limitations connected to the human competence and ability?
Yeah, I think as we said, the things that are experienced, that you feel or hear or see, that could be a limitation in VR, because you can practice a method and you can also look at different things, but the feeling is still a limitation, I think, in VR and mixed reality. Otherwise, I think it's getting as good as it can be, I think.
So we are quite mature, actually, where we are today.
So. Yeah.
So Mike, maybe to comment that this, what we have right now, could that really support the industry to take this step into the digitalization?
Yes, I think that is really the case. When we engage with customers, it's often the case that we get into the discussion that we actually have a good match in their transformation initiatives. So actually, the goal is to reduce the number of physical prototypes, for example, and it's not a technology discussion anymore. It's rather a business process discussion. How can these KPIs, less cost of physical prototypes that, as Stephen said, are available quite late in the process, and with all these configurations, it's anyhow not possible to, let's say, have a good coverage of design reviews in different configurations. So for sure, there are still topics to solve to play all these configurations through in virtual reality or extended reality. However, from, let's say, the potential that we see already now, this is clearly the path.
So this is possible now. It's not tomorrow. It's now.
No, it's happening now.
And it's creating, as I understand, that it's important virtual trust, that you could trust the data, you could feel, and you could experience. As you said, Steve, you could make the decisions on the digital data. So Steve, back to you. These are now used in projects. It's used in the development process. Is there any other areas of application within the company?
Yeah. I mean, again, we've started with it in the product development process. I mean, it fits very naturally. I think there, we're working directly then with the people that are developing the parts and the design. So I think that's been a very natural place to start. Again, if you think about what different applications there could be, again, we have this, vast amount of different options and variation within our products. So again, it's not just the product development when you're bringing a new product into market, maybe where we could use this, but in communicating with customers about specific configurations, that could be really useful. Again, in the industrial sense, when we would build a large customer order, we would often build a single truck first as a pilot, and then the rest of the order later on, to have the ability to look at that truck, make sure that it was configured in the way that the customer really wanted to. But you can imagine, I mean, if you could do that in VR in the first place, and again, bring that one-to-one, visualization, that could be very powerful in being able to communicate with the customers as to maybe different options they could have, or to make sure that that configuration is what they expect.
So you mean inviting customers to customer clinics, maybe not even on the same site, experience the product that they would like to order?
Yeah, I mean, that could be really, again, a very interesting application, I think.
So Greg, if we look from that perspective to other XR use cases, I guess you are supporting a lot of different, let's say, industries and applications.
Right, and I think, you know, that next level, the customer, right, the person really unfamiliar with XR, right, getting that ease of use to where I can send a headset to a customer in a different state or a different region, and I can use, you know, AWS, Azure, Google Cloud, what have you, and put the experience there. In fact, just recently, I experienced a car in my front yard, right? So that, and they could have just emailed me an Oculus Quest 2, $300. I walk out in the front yard and I get to do a detailed design review on a car that I'm ordering, or a truck I'm ordering, or in the architecture space, I get to walk through a full-scale model of a remodel or a building. As long as I have a big enough space to walk around in, you know, I can really get a feel. We're remodeling our home just like everyone is during COVID, and I made a comment to my wife, every room seems smaller in real life than I have it pictured in my head, right? So, you know, the furniture's too big, the cabinets are too big, what have you. That at scale experience going to the consumer will just, you know, consumers will see what they're buying and be able to do it virtually and long before change orders are made. So construction will change, you know, how you pilot a truck. You know, your first pilot will be virtual, and that's just lowering this ease of working with data. So we've always talked about human computer interaction. We're really getting to human data interaction, and if we can get consumers, if we can get buyers really easy interaction with their data, the data they're going to buy in physical form, we've really crossed a threshold. And then, you know, training just follows on to that. That means the training environments are more realistic, easier to get into, and you're interacting with the environment, not the technology. So, you know, this all to me is a move into the human data interaction, and we're really at a bright early spot right now.
So we will all wear an HMD or have an HMD in the future.
I have, you know, 3 or 4 of them, so that's my expectation, right? Everybody should. Yeah,
that's good. So also, could that be applied to other industries? We talk a lot of trucks and cars and automotive, so other industries or small, medium enterprises.
Yeah, I think so, and I also think that this is not only focusing on the product, but also the production and production development. It could be used for risk analysis in production, for example, or ergonomic analysis, or as you said, showing your production as part of a selling point as a small and medium-sized companies to bigger companies, for example. So I think it could be used for many different ways, and we work with human-centric automations. We look at how we can use automation to secure the operator and the space or the workspace for the operator. So I think in production and safety of the production, it could be used also in much more degree than it's today.
So if I'm an equipment supplier, I could join in a virtual session showing what my, let's say, equipment, how that could feel. Okay. That would be great. So Greg, any comment from your side on that from another industry or small, medium enterprise perspective?
Yeah, I think that's really critical, because, you know, we talk about data centers and machine rooms and serving VR from that. And that typically, when we say data center, we think of a really large company. But if you think of a 4 GPU desktop server, right? Suddenly you have, you know, 4 to 8 users in a virtualized environment. You have a small office that can jump in and out of VR anytime they want with just headsets for everybody. And when they're not using those machines, you know, for VR, they can stream their virtual desktop or CAD packages, design packages from that. So we're talking anywhere from, you know, a few people with a reasonably priced server, all the way up to the large companies with machine rooms and then prototyping in the cloud. So there's I think room for everybody to play in this, and the market will push us onto, you know, dropping that total cost of ownership for the GPUs. The market's going to ask for more and more users per GPU. we'll respond to that in new designs and such. So I think you'll see the costs go down, and there's already options for small to medium businesses. So it really is an interesting time.
So it will not be more expensive, then it will be less expensive moving forward to leverage the technology as a stand.
That's where things tend to go, and I see that happening, right? Even the headsets everybody's fighting to keep their headsets in the hundreds of dollars, and we'll see the GPUs need to support more users. And right now it's a really interesting time, right? The GPUs have been powerful enough to drive an XR experience for a while now. And now that we're streaming, I have to start thinking about the encode part of the GPU. So it's not just the rendering part, it's now how much encode can I do? Because 90 frames a second stereo high def is a lot of encoding. So that's my new bottleneck, is the encoder. So we'll balance those GPU power, encode, network density, all that stuff will continue to refine, and we'll, as soon as we meet a new bottleneck, we'll clear that out of the way, and we'll get higher density systems that will drop the price per person. The way I see the market heading anyway.
And Michael, IC.IDO has been in the business for a long time. It started with CAVE, Powerwalls, then HMD came. What's your perspective when it comes to the democratization?
We had it in the discussion. It's now mature technology, and there is a certain momentum for scale, and our company or clients, they really are interested in also mobility, and that's maybe the biggest disadvantage also, aside the high upfront investment of caves and Powerwalls, that they are immobile. And I think the demo, which we have not talked so much, but actually that is a very mobile thing. It's a pop-up XR environment that we set up there. If Volvo decides to move that to another building, that's not a big issue. And this is why I think that the trend is clearly going to the mobile devices, in particular the headsets and the next generation headsets that allow for, let's say, a much more detailed interaction with the product, including, let's say, the pass-through abilities to have the extended reality, as we have seen with the leather as a good example.
But how to get access to the data and the digital thread? How do we solve that?
Yeah, today we, let's say, can consume very well all the relevant CAD data. We are extending that to kinematics, predefined, and working to be very closely integrated into the PDM PLM backbone. And actually the vision is to really have a very efficient solution to review the different configurations that Stephen is mentioning, that connection will allow for that.
And that's important, I guess.
Yes, that's also mission critical, I think, in the transformation process.
So we have seen a little bit where we are coming from. Both Greg, Steve, and yourself talked about the past. We know what is the present. So what about the future? Steve, what's your vision 3 years from now?
Well, first of all, I'm excited where we've got to now today, right? So I think really utilizing the new collaborative VR, that's going to be an exciting journey here the next few years. And then I think to continue to work on the ease of use, the ease of setup. I mean, that's key. And I think we touched on it very briefly, but I mean, one of the challenges then with these headsets is how do you manage the security of those into our networks.
Good. And Greg, what's your vision?
Yeah, it's very simple. Some near-term items we have to clean up, and security is definitely one of them, right? I equate that to Yeah, I worked I was academic before I came to NVIDIA, and part of my job was in the hospital with radiology, and doctors carrying cell phones around was a real issue early in. You know, how do we secure those cell phones with patient data running around? The headsets are very similar, right? Here's a mobile device. It goes everywhere in the network. How do we secure those? How do we recognize those? How do we encrypt those? And you know, one place, we're not sending data to the headsets anymore. We're just sending frames. So in one instance, we've already gotten a little bit more secure, but now we have to look at encryption and authorization and certificate trading. Those are all technical features that should clean up in the next year or so. And then I really look forward to the AI events, right? I want to talk to my data. I don't want to use a GUI. I've been in the human computer interaction, the biz place, for 25 years in my career, and I want to stop clicking on keyboards and mice and controllers, and I want to just interact with my data. I want better motion tracking. I want, you know, a conversational AI, and I think that's all coming in the next 3 years. We'll see great advances in those areas.
So even more simplification.
More simplification, right? Really mixing with your data, and you know, whether it's scientific data of a big CFD simulation or a design review, you know, the closer I can get to just touching my data, the better. I agree the haptics are a ways out. We've been working on graphics for what, 30, 40 years, and we're just starting to work on haptics, so they're going to trail. But you know, at least we're getting to motion and see the data beautifully, and that interaction just gets better and better over the next few years.
Thank you. So from a research and university perspective, also, where do we need to invest in order to, let's say, get to the vision in 3 years from now?
Yeah, I agree with both of you. Both the haptic, as we said. I also think the ease of use is a big changer. And I also want to communicate, but also to be able to codify the data and to turn the data into information and knowledge from the session or the VR session. So that is also something that we are looking into. How can we codify or turn data into information and knowledge and feedback loops?
So feedback loops to get quicker and to onboard people.
Yeah.
Michael, do you have any vision to add on top of all the visions we have?
No. First of all, I mean, what Greg said, that really inspires me, the coupling with the AI. Yeah. I mean, talking within the immersion, having no interface, because I think especially user experience, that's so important. And I take that as a takeaway from that panel discussion. And aside that, I think, yes, it would be great if we are in 3 years in a state where basically the normal work hardware for an engineer is not just a laptop, or it's a laptop and a headset, and he can basically at any time switch and let's say connect to others or review his own work, and it's simply super easy. Yeah, I think that is a good vision for us.
Good. So let's move from the panel into the Q&A. So seamless, let's say, next step. And we have received some questions. That's why I'm having my phone here. So if there is any more questions from the audience, please chat that. And then we start with the first one. So usually when people test VR, also they see desktop simulation. They say that they lack feeling for the product, even weight on the article. How to get them, and how do you respond to it today? Do you want to take that, Michael, or?
I mean, it's you basically mentioned the limitations. So gravity is we simulated with our real-time physics solver. The representation is basically our vectors. It's visualized. However, I think really in full virtual reality, we will have difficult constraints. However, I think in mixed reality situations, we have much more options to take, let's say, critical equipment in the scene, and there are good use cases actually where exactly this is happening with a well gun, for example. So I think in this direction it will move. Maybe some areas will be difficult in full virtual reality to address. However, in mixed reality, I think we have very good options to address that.
Great. Any comment from anybody else on that one, or should we move to next question?
I'll just make a quick comment. I think that's a really intuitive thing to think about, that mixed reality being a gateway while haptics improve is a really nice way to think of that, you know, as that subtle improvement in systems. You know, haptics is doing some nice work in the haptics, but it's still, you know, it's a heavy lift to get the haptics up to the graphics level. So the MR as a gateway is a really appealing idea.
Great. So we have another question here related to the demo. So we saw 4 headsets. Are they all connected to the same computer? If not, how are they connected to the environment? So maybe Greg, from a CloudXR perspective, do you want to answer that?
Sure. With CloudXR, you know, we have a Steam VR interface, and Steam VR is one-to-one right now. So each of those headsets would be connected to its own virtual machine. So it might be a single server divided up into virtual machines, but it's a machine per user right now in the streaming, in the CloudXR build.
Yep. How have you seen business attitude and investments toward visualization changed as a result of the pandemic? So maybe Steve, from a Volvo perspective, do you want to reflect on how important the investment in these technology are from a, let's say, pandemic, or let's say after pandemic perspective?
Yeah, I mean, you know, obviously during the pandemic, then, you know, we've been in a situation where people have been, you know, working from home. We have seen continued use of, you know, smaller VR setups, where again you have, you know, an expert in VR that's doing the study and other people, you know, following that remotely. So that work has continued. You know, obviously then the setup that we've had in the room, where we've had a group of people, I mean, we've done a lot of work developing that, but you know, we haven't had as many people in the office. Now we start to see people coming back in. So yeah, it's going to be, again, I think once we have people in the office and that interaction that we have, you know, that's when we see the collaborative VR setup we can start to use more.
Any reflections, Greg or Michael, on let's say the pandemic?
I think it's really interesting. The pandemic has certainly taken away our access to physical prototypes, right, at the shop, at the factory. And so maybe we've started relying on visual data more, digital. But I think the growth in visualization, with, you know, getting visualization instruments closer and closer to the PLM or the BIM, and getting that data in, and the desire to visual prototype instead of physical prototype, I think that's been a trend, and maybe just the lack of being able to get to physical prototypes is what the pandemic has accelerated for visual. But we've seen the visual arts, right, the visual interaction with your data increasing year to year, no matter. But I do think, you know, we had to take a break from physical prototypes in the plant for a couple of years now, right, year and a half or so.
Yeah, and I mean, if I can add something in here too as well, I mean, one of the benefits, you know, of virtual, and we've talked about it a little bit here, I mean, is the ability to share between different sites, right? Have people interacting from different places around the same virtual data. That's a big, you know, benefit when we look at virtual data. And you know, maybe in some ways the pandemic has forced us all to work in different ways and maybe accept the idea of you know, maybe traveling less and doing more of this interaction virtually. So, you know, before, again, we would have sent a team somewhere to a plant to go for a review. I mean, again, this offers also some opportunities to be able to do some of those reviews in a more efficient way.
And I think I speak for everybody. My schedule has gotten so busy with meetings since I've stayed home that I don't have time to drive to the airport any longer, right? So I'm not sure how that happened, but yeah.
And I guess nowadays it's not only, you know, short and lead time and reduce cost, it's also a sustainability topic.
Mm.
So we have one question here related to combining different, let's say, hardware. So we have the HMDs, we have the surface, we have the computers. So how do we combine them together in, let's say, the CloudXR and VR environment?
Yeah, I mean, it's a mix and match. So it's really fascinating to see all the headsets coming out, all the all-in-one headsets now, right? So this advent of streaming XR and all-in-one headsets means you can easily, you know, VMware, for instance, launched yesterday in their conference the beta of their XR system, and it supports Vive and Oculus and Pico, and so you can mix and match the headsets with all the hardware now. We'll see the various operating systems, you know, normalize. I think we'll see a transition from Windows to Linux over the next, you know, maybe 5 or 6 years. So we'll start seeing, you know, Kubernetes container workloads that are VR workloads and managed on the clusters. And so the equipment will kind of go away, right? We won't think that much about mixing equipment. We'll just buy the headset we want to and hook into whatever stream is on our plant. So,
or using a mobile or a tablet and join maybe a session.
Yeah, I mean, also since we see the different roles and not necessarily everyone need to be fully immersed. So there might be a program manager very interested in, let's say, getting a quick overview of all the issues found by the different engineers doing the actual review. And maybe he's then better working with a tablet, having his, let's say, wash-up manager listing up all these issues that were detected. So I think it will be this kind of scenario that we will see.
Yeah, I see time is running. We are a little bit over the time of the event, so I think we'll round up here. I think there are some more questions that are coming and still coming. We will try to answer them individually. I would like to first start to thank you, Steve, and Volvo. You put the vision, and we were able to also share the demo supported by you and your colleagues today. So thank you for joining. Thank you, Greg, for taking the perception from a NVIDIA perspective, been a long-term partner to ESI and IC.IDO. And then with us here, Åsa, for joining, and also Michael. And also all the people that have attended today. I hope it has been an interesting afternoon, that you have learned things that you would like to, let's say, take with you moving forward. And this was our second XR event. We launched the first one last year digitally, and I think we will be back with the third one quite soon. So thank you and have a nice day.
thank you.
Thank you.